Malaysia. Terima kasih kerana anda memilih untuk berada di konsert Siti Nurhaliza on tour. Sampai keresahan dari jiwaku ke diri. Inilah nyanyian karaoke yang paling best. Nyanyi ramai-ramai.
Assalamualaikum and a very good day to everyone. Welcome to Siti Nurhaliza concert in Kuala Lumpur. So we are from Group 2, so today we would like to present our group project for process optimization. So these are the outline for our presentation. We will start our presentation with the problem statement. Next is optimization, formulation, solution with discussion, sensitivity analysis by using Excel solver, and lastly is binary programming by using GAM software. Problem statement. An organizer offers premium, standard and economy seats for Siti Nurhaliza Tours concert in Kuala Lumpur. The organizer is targeted to sell a minimum of 150 economy seats to be profitable. Since Malaysia is currently having movement control order due to COVID-19, there is a limitation on number of total guests that can only accommodate a total of 500 guests. The number of seats available for premium and standard are also limited to 100 each. So this table shows the comparison between different tickets that will be sold in the concert. In order to maximize profit from ticket sales, the organizer wanted to know the number of tickets that need to be sold from each classes. Other than that, the organizer is also planning to increase the price of economy ticket to increase the profit. Therefore, the data on allowable increment from current price is needed to determine the maximum range of the price of the concert that can be increased without causing reduction in numbers of the tickets sold. Next is optimization formulation. For objective function, our objective function is to maximize the amount of profit from ticket sales. So our objective function equation is P equal to 800x1 plus 500x2 plus 300x3. So from this equation, we know that we have three decision variables. So x1 indicates the number of premium tickets sold, x2 indicates the number of standard tickets sold, and the x3 is the number of economy tickets sold. So for constraint, we have 5 constraints. The first constraint is the maximum number of premium tickets available, which is constraint number 1. x1 must be less than or equal to 100. The next constraint is maximum number of standard tickets available. x2 must be less than or equal to 100. Minimum number of economy tickets that need to be sold to be profitable. Constraint number 3. x3 must be more than or equal to 150. Maximum capacity of guests, which is the total number of tickets, which is x1 plus x2 plus x3, must be less than or equal to 500. And as we know that x1, x2, and x3 is the number of the tickets sold, so it is not possible to have a negative value. So we will have our non-negativity constraint. So we will have here x1, x2, and x3 will be more than or equal to 0. Then, after we input all the decision variable, objective function, and constraint into the Excel, we get the number of premium tickets sold, which is x1 equal to 100, the number of standard tickets sold, which is x2 equal to 100, and the number of economy tickets sold, which is x3 is equal to 300, with the maximum attainable profit is Rm 220,000 ringgit Malaysia.
Next is sensitivity analysis with discussion. The problem statement is adjusted to the first condition, which is to analyze the sensitivity analysis by changing the objective function. The sensitivity analysis report shows the allowable increase and decrease for the parameter that has been inserted. The aim of this project is to change the price of academic ticket based on the allowable increase to analyze on how the objective function is affected. If the organizer decided to increase in the price of academic ticket, this will lead to increment of the profit. So in order to anticipate the increment involved with the new price, we can refer to the sensitivity analysis table that produced by the Excel solver, specifically the variable sales table. Based on this table, taking the price academic ticket X3 as example, the allowable increase of the company ticket is RM200, while the allowable decrease of the academic ticket price is RM300. Next, the sensitivity analysis report will change by increasing the price of economy ticket within the allowable increment. The range of the allowable increase and decrease mentioned in the sensitivity analysis indicates the allowable increase the economy price ticket without changing the optimal solution that we proposed earlier. As an example, if the increment of the ticket increase within the range, which is increasing from RM300 to RM350, it increase of RM50 from the initial ticket price. So the amount of X3 that need to be produced will not change. Therefore, the profit obtained from this case is RM235,000, which is increases by RM15,000. Increasing the price shows a significant change. However, there is no change in the values obtained at the constraint, which is the number of tickets to be sold. Next, the sensitivity analysis report changed by exceed allowable increment. If the increment is outside the allowable increase value, for example, if the economic ticket price, which is X3, is changed to RM550 ringgit, where it exceeds the price by RM50 ringgit, the amount of X3 that needs to be produced will change, and this will directly impact the overall profit. The table shows that by purchasing full amount of premium tickets and maximum amount of economic tickets, it will yield the highest profit. Nevertheless, the price ticket of the economic class is not feasible since the value is higher than the standard price. In conclusion, we need to monitor the price of the ticket so that it will not affect the optimal solution proposed previously. Next is LP programming using the GAN software. So it is found that the result produced using the GAN software is same as the Excel solver.
The next part for the project is binary programming. Due to the deadline of ticket sales is getting closer, the organizer has given 4 proposed ideas in order to maximize the profit of the ticket sale by making sure that the ticket is sold as much as possible. As an engineer, I need to prove whether the idea given by the organizer is beneficial or not to the concept. The first proposed idea is that if the customer wanted to buy premium ticket, they also must buy economy ticket as a set. Next, if the customer wanted to buy standard ticket, they cannot buy economy ticket so that they will only pick the more expensive option. The third idea is that if the customer wanted to buy premium ticket, they must buy either economy or standard ticket. The fourth idea and the last idea is that if the customer wanted to buy premium ticket, they must buy both economy and standard ticket. So, this optimization problem of binary programming is solved by using GAN software. This is binary programming with discussion for proposed idea 1. If the customer wanted to buy premium ticket, they must also buy economy ticket. For the discussion, if the premium ticket is selected, then the economy ticket must also be selected. This means that the premium ticket depends on the economy ticket. We can categorize this proposed idea as conditional constraint. The equation that we can deduce is x1 is less than or equals to x3, or x1 minus x3 is less than or equals to 0. From the result shown in the GAN software, we can conclude that the maximum profit is achieved. After that is proposed idea 2. If the customer wanted to buy standard ticket, they cannot buy economy ticket so that they will only choose the more expensive option. For the discussion, if the standard ticket is selected, economy ticket cannot be selected. This means that the standard ticket and economy ticket cannot coexist with each other. For the constraint, we can categorize it as a mutually exclusive constraint. We can deduce an equation by writing x2 plus x3 is less than or equals to 1. From the result shown in GAN software, we cannot achieve the maximum profit as we only can achieve up to 20,000 instead of 22,000 that we get from proposed idea 1.
The third proposed idea is if the customer wanted to buy the premium ticket, they must buy either economy or standard ticket. So, this proposed idea is similar with the proposed idea 1, where the premium ticket is depends on either standard ticket or economy ticket. Therefore, this proposed ticket idea can be categorized as conditional constraint. we can deduce the binary equation as x1 minus x2 minus x3 equal to 0. So from the result given by the game software, we can see that the maximum profit achieved by this proposed idea is only 200,000, and therefore it is not achieve the maximum profit that we can get, which is 220,000. Moving on to the last proposed idea, which is proposed idea 4. So the proposed idea 4 is, if the customer wanted to buy premium ticket, they must also buy both economy and standard ticket. So this proposed idea also conditional constraint, where if they want to get the premium ticket, both economy and standard ticket must be chosen. Uh, from the discussion, the binary equation can be deduced as 2x1 minus x2 minus x3 less than or equal to 0. So by computing it into game software, we can see that the maximum profit that we achieve is 220,000, which is the maximum amount that we can get. Therefore, uh, by doing this kind of proposed idea, we can achieve maximum profit. So, in conclusion, it is found that proposed idea 1 and 4 can be performed to maximize the profit of ticket sales compared to proposed idea 2 and 3. Since the demand of the concert is high due to the probability of Datuk Siti Nurhaliza and the limited seat available, proposed idea 4 is the best to be executed to further boost the ticket sale. By doing so, the premium ticket can be finished in short time together with standard ticket. Meanwhile, the economy ticket is already sold by 100 ticket and only left with 200 ticket. Therefore, the ticket sale can be finished faster and meet the deadline. That's all from me. That's all from us. Thank you.